Hello, my name is Mike Emerson. I am the owner and creator of the EEi software. My EEi software has 10 major electrical categories. These categories were selected from the 10 most used electrical issues that drives our electrical activities in design, estimating, bill of material, brownfield revamping, and greenfield new projects. For demonstration purposes, I will use 4 of the 10 categories. 1, the 3-phase transformer program. 2, the 3-phase motor program. 3, the voltage drop program. And 4, the cable tray program. These programs working together will show the powerful abilities and supply needed information to complete projects. To assist my EEi software, I will use an electrical equipment arrangement plan view drawing, simplifying calculations for the viewers. For this demonstration purpose, I will route the T1 30 kVA transformer and the 40 horsepower motor feeders from the MCC building using the minimum cable tray usage. Okay, let's begin with the transformer program. First, let's review the T1 30 kVA transformer design. Turning on help tips will guide you through the steps to create your transformer design as needed. These will give you the instructions as you go through the procedures creating your own transformer design here. First is this is the panel, the field panel information, which is the secondary side of the transformer. This is the transformer voltage and amp side. This is the primary side of the transformer and the secondary side of the transformer. We will begin with instructing our program the panel size that we need. We need a 3-phase and we're going to need a neutral. And for 30 kVA, I know by experience it's 80 amps. And the voltage will be a 208 on the secondary side. The primary side, of course, is going to be a 480 volt. And if we plug in our primary circuit breaker, we will now see from our MCC source, which is substation MCC building, to the primary side of the transformer itself. It's showing a 3-conductor number 8 with ground. Of course, in red right below it, it also states that voltage drop is not included. So with this information, we need to record now with the amps needed to check for a voltage drop. In just 1 minute, let's also look at the motor design as well. I didn't need to do that. Let's leave up the motor. Let's leave up the transformer design. Put it back to where it was. We will leave this transformer design as it is, and now we'll look at the motor design. Again, we had a 40 horsepower motor. Voltage will be 460, 480 volts. Our horsepower, of course, is 40, and the type of cable that we were going to be running is XHHW. This side here, this is the needed characteristics for your motor design, and this is actually the visual design giving the operator a more conclusive understanding of the physical application of what he just asked the characteristics to do. Okay, with this information here, now we need to go to the voltage drop, and using the previous transformer motor information, we will use the voltage drop program to get our correct feed sizes to the T1 30 kVA transformer and the 40 horsepower motor. Okay, with this information available, we'll go to our voltage drop program. And we need the information here and here to actually size for our distance and voltage drop to make sure that we have the same needed capacity and cable size to furnish our primary side of our transformer and of course our 40 horsepower motor. So to start with, let's take our transformer first, and it's a 3-phase transformer using copper conductors, and the conduit type will be steel. Required voltage here, it's transformers 277/480. And at this point here, we are asked the voltage drop program to help us out with the conductor size. Well, the conductor size is what we're looking at right now, is a 3 conductor number 8. Now, distance from here I've already calculated is 800 feet. And the required amperage that we're going to need to actually push our transformer will be 36.08 amps, or we can say 37 amps. And here we'll calculate it, and the voltage drop is still showing way too much. We need to be at 3% or less. In order to correct this here, if it's too high, we increase the conductor size as needed. I know the size of it is going to be a number 2, and to save time, and we'll go ahead and put the number 2 in there and calculate it again. Our voltage drop drops this time below the 3%. We got a 2.125% here. So with that information, we're going to use an XHHW conductor, and it's showing that our conduit is 1 1/4 inch in diameter. Okay, that's the information for one. The next one will be for the motor itself. We'll reset. Again, it's going to be a 3-phase here, and we're going to use, of course, copper conductors, and it's going to be steel conduit. Again, we're asking for the voltage, and it's going to be a 460 because of this being a motor. And the type of conductor, we can start with a number 6 for the demonstration purposes. And again, I know that this is 750 feet, which I've already estimated. Motor, the necessary amperage is full load current, which is 52 amps. And we're going to calculate the number 6 as it is right here, and we're showing a 6.5 or 6.6 voltage drop percentage. Now again, we have to be 3% or less, increase conductor size as needed. Okay, let's go to a number 2 again. I know after calculating in the background that this is number 2, and to save time, let's just go ahead and calculate it. We're showing a 2.9 voltage drop here, which is good. So with this information here, that we're also going to need a 3 conductor number 2 supplying our feeder for the 40 horsepower motor. Okay, with this information recorded here, as well as for the transformer, we're going to reset and get out. And we can do the same thing with the motor here. Let's go ahead and reset it and get out. Now, to actually do as I promised, I want the minimum cable tray usage from the MCC building down the pipe rack here and here to supply our feeders for the T1 30 kVA transformer and the 40 horsepower 3-phase motor. To do that, we will actually open the cable tray program, and we can put a title in here. So let's go with oil refinery. And it's showing the actual date here automatically. You can change that date if it's necessary. And here we're going to put in our cable numbers, which is we're going to just use a generic C001, and again cable tray number, and we're going to use another generic CT001 for the cable tray number. And the first conductor for the transformer was a number 2 with a ground, so it'd be a 2 AWG with number 6 ground. And this is going to be a 3 conductor, and we want to add that to our cable list for the cable tray. Okay, so the cable tray is being sized according to the cables that we're putting into it, of course, and here it's showing that our Minimum size is 4-inch cable tray. Here's the summary of our information. Your 4-inch tray is availability, or available square inches, and the total cables inside your tray is 1. And if your tray is being measured at 80%, or some of the cable trays are measured for future use, it will give you this square inches, and the tray fill at this time is a 0.75 square inches. You can add the second cable that we were looking for. Again, this is cable 2, and the cable tray will be 001 steel. And again, we are looking for a number 2 3 conductor. We want to add it. Okay, it's still calling for a 4-inch cable tray. So our cable tray that we're going to run here, minimum size will be 4-inch. We can add this summary to our list here, which is showing what we have at this time and the fill of the tray and the minimum size of the tray as needed. Okay, it asks us, would you like to save your cable list changes? You can say yes and go in and change it to whatever you want to per your project or for your personal need. I'm going to put cancel now because I'm not going to save. And at this time you can edit anything you want. You can edit the project name, so on and so forth, for the cable number, cable tray number, the size of the conductor. This cannot be messed with. This size here is, if you mess with it, you have to restart your cable size, and again, because it is recorded information right now, if you change this information now, it does not recalculate the cable tray unless you restart it. Okay, with that said and done, the minimum cable tray that we need is a 4-inch cable tray. We're pulling 3 conductor number 2 cables with grounds to the T130 kVA transformer and one to the 40 horsepower motor.